And for my CBT for stochastic calculus, I had to do a question on question 3 of a presentation. Suppose that the current price of a stock is $45. The stock has a volatility of 25% and pays continuous dividends at 3%. The continuously compounded risk-free interest rate is 7.5%. A customer buys a put option from the market maker with a strike price of $44.5 and the time of maturity is 91 days. The call is written on 150 shares of the stock. So based on this, we should take note of the current price of the stock, the volatility, the dividends, the free interest rate, the put option, the strike price, the time to maturity, and the 150 shares. Continuing, we will have the table of 41 days in total, with each day corresponding to each individual stock price. So now, the buyer wants to delta hedge his position by buying shares of the stock at 0. So the market maker will now then rebalance his portfolio every day as the stock price moves. So now we should have to compute his profit or loss every day in 41 days if the stock price moves as in the table. So based off that, we should first grab all the values that we got from the question: the current stock price, the volatility, the dividend, the risk-free interest rate, the strike price, the days, the number of shares, and the put option. So T is basically the time in years. So we just convert the days into years. We just divide it by 365. And we also collect all the days. We convert them from 0 to 41 with each corresponding stock price. So let's take the day 0 for example. So for day 0, we will have no time to maturity because it's the first day. Day 0 is the first time. So T, so the small letter t, will be ignored. So following that, we can calculate D1, D2 under this corresponding formulas with T, small t equals to 0 because your day is 0. From that, we can see that D1 is 0.241 and D2 is 0.117. From that, we can get the normal distribution of n negative D1 since it's a put position. It's a put position option. Now, we just need to use the Google Excel formula norm as this of negative D1. Same goes for D2. So each D1 and D2, you can see that it corresponds here. The price will also be under this formula, which will be $1.74, and the delta is also under this formula, showing the delta formula. So now, with that, we can first see that the time to maturity, which is T multiplied minus the day. So you get the first T, which is 0.24932, minus 1 over 365 because we want it in years. So for that, we just calculate for each one through Excel. We can drag it out and we can see that all numbers correspond. Now we need to calculate the change in stock price, which is basically the change from day 1 to day 0, day 2 to day 1, and so forth. So from that, we can use D31 minus D30 corresponding to each cells. And then we can drag it down to see that it all stays the same. This goes for D1 and D2. We go by the formula as stated above. We use Excel's formulas to compute it for us. And we can compute for each one and all the way down to 41 days. Next, we need to find the put price and the delta, which can also be used under the formula that was given. And then we can find each corresponding day of the put price and the delta. From that, we need to find the change in put price, delta P, which is day 1 minus day 0. After that, we need to find the variable v, which is basically the number of shares multiplied by the long put price, which is basically 150, the number of shares, multiplied by the long put price. So we can drag it down for each individual day, since each individual put price is different. And then now we find the number of shares purchased or sold, which is also basically the delta of 150 long puts. That is basically 150 multiplied by the delta. So based off that, now we can determine the worth of each shares that is purchased or sold. This each worth is basically the number of shares sold multiplied by the stock price. After that, we can compute W, which is basically negative V plus the stock price plus the delta of 150 long puts. Multiplied. So from that, we can compute for each corresponding day. Now that we have computed all this, we can now calculate the profit or loss for the short position of 150 put, the long position in the stock, and the short position of cash. With that, we have the first one, the short position, which is basically the number of shares multiplied by the change in put price. As you can see, 150 is C10, as stated here, multiplied by the change in put price. And then we have the delta of 150 long puts multiplied by of the day before, multiplied by the stock price of today, which will be multiplied by the exponential of the risk-free interest rate, the dividend, multiplied by the time to maturity, the difference in time to maturity. After that, you minus it by the stock price of the day before, and that will be the profit or loss in the long position. The profit or loss in the short position will be the W of the day before multiplied by the exponential of the risk-free interest rate divided by 365, to put it in years, minus 1. And all of that will be multiplied by W. Yep. So based off that, we get these three values, and now we just need to sum it up, and we will have the daily profit or loss for each day. And here is the graph to what it looks like. Thank you very much.